Hello everyone. This video will go through the way of how users can submit a job or a calculation on a HPC cluster that uses the PBS queue system. Okay, so there's a few things or a few ways of doing this. On this cluster there's two different type of jobs. One is called a batch job, which is submitted to the queue, is then considered and can run at any time basically, and the user has no ability to interact with this job. It's basically sent off and then the whole calculation has to run on its own without any user interaction, and then the user picks up the results when things are finished. We're going to come to that in a minute, but the first one we're going to look at is what is called an interactive job, and that is a way that a user can request basically a login on a compute node to carry out calculations interactively from the command line as if they would use a server or their own desktop or laptop. So we're going to start with this first to go through all the different options that are required to submit a job, and then we're going to translate that in the end into a batch job submission. Okay, so the command to submit a job is qsub for submission, and we're doing an interactive job, so there's a minus capital I here. On this cluster and many other HPC facilities, there will be groups or accounting groups or accounting projects that a user has to supply. So on very, very large facilities, most access is granted through a research project, and then a user would have to give that project to be able to account this job for this particular project. And on this cluster, you also need an accounting group, and that is done by a minus capital A. Sometimes if it's a project, it might be a minus capital P for project, and then you have to give the project name or the accounting name afterwards. Now, how do you find that out? Okay, so on this cluster here, I'm going to type groups, and that will show all the different groups, including accounting groups, this account has access to. And so on this one here, we're after the ones starting with UQ. On other groups, you might be part of different projects, sometimes 1, 2, or 3, and then you just have to choose which one is the appropriate one. So going back to the qsub command, we have a minus capital I as the interactive one, a minus capital A for the accounting group, and that is UQ AIBN in this case. So what do we have to ask for next? So all HPC facilities will require that users request appropriate hardware resources for their jobs. And that is because a job might be sharing a compute node with another job, and so you can't get the whole compute node for yourself or can assume that the whole hardware is available. And so to enable sharing of compute nodes by 2 or even more jobs at a time, users have to specify a limit to the hardware resources that they're going to use. So the hardware resources are the number of cores, and then also if a number of compute nodes that might be in use, And then the number of cores becomes how many cores on each of those compute nodes. Users will have to request the amount of RAM or memory that is required. And in some cases that can be done per node or for the whole job, or in terms of per core. You will have to find out, depending on what HPC you're running on, what are the ways of requesting these. And so for this cluster, you request resources per compute node. And so the way of doing that, a minus little l will always signify a resource request. And so the select request will request nodes, compute nodes. And so we're going for, I want for this job a single compute node. And for interactive jobs, that should always be the case. And then the next one we're going to request is the number of cores per node. And so here the colon signifies that this is a per node thing. If you have a comma in some of these requests, then it's usually a per job request. So there's very particular syntax, and again, it's best to check the user guides for the HPC you're using to make sure you're using correct syntax for what you want to do. So we're going to keep with the per node, and so the colon request. And so number of cores are requested by ncpus. It's a bit confusing that talking about cores, but then you're putting in CPUs. But that's just legacy notation, basically. Okay, so we are now requesting the number of cores, and for the purpose of this interactive job, I'm going to ask for one single core. And now the next one we're going to do is the memory or the RAM request, and that is done by mem, short for memory, and I'm going to ask for 5 gigabytes. And so this whole request basically selects a single node, a single core on that node, and then 5 gigabytes of RAM for that single core for the whole job, basically. The last thing we need to ask for is the approximate or the time that we need for this job to finish, and that is called the wall time, and it's another job resource. And so we need the little l in front of it, and then wall time equals, and wall time is given in hours, minutes and seconds, and so no one should ever bother with the seconds, so we're going to ask for an hour. That's a 1 in front here, 00 minutes, 00 seconds, so that gives 1 hour of wall time. It now should be noted that these are fixed resources, and so if the job is running and the hour is up, the job will be automatically deleted. The same is true for the ncpus and the memory. If the job is trying to use more than it has requested, again, it will be automatically killed because it's trying to use more resources than were requested, and because it's a shared compute nodes are a shared resource, and not to endanger any of the other jobs that are running on there, any job that doesn't stick to the requested resources is killed. Okay, let's see what happens when I press enter now. Okay, qsub is telling me waiting for this job to start. It's now saying the job is ready. Execution started, and then it's actually giving me a job ID, my username, and it's giving me the execution host. And anyone who has a very good eye would have seen that now my prompt has changed and I've moved from the login node to the compute node this job has been assigned to. And now I can basically type anything on here on the command line. I can load a software module, I can bring up our Python and run things as if I would be on a server. And I've got this login on a compute node for 1 hour with these resources, and so I can do any calculation that is happy to run with these resource limits right there, and by just typing it in and pressing enter. So this is an interactive job. It allows a user to do testing, for example, if you want to do testing of your workflows or the commands you need to put in to making sure everything runs through and smoothly. If you want to get an idea of how things work and how long things might take. And then, or if you actually have to interact, like put input in during the calculation and things, or type something on the command line that the job needs, that's a way of doing this, is by doing an interactive job. And so this should prevent any user from running on the login nodes, because you can always get an interactive job really quickly to do these things on one of the compute nodes, where any calculations, no matter how quick or short or small, belongs. Okay, once you're done with your testing or your interactive job, if it comes up to the wall time, so when after an hour is up, it will be automatically cancelled and you exit. However, you can exit an interactive job anytime by typing exit on the command line. And so now it's telling me that this job has been completed. So that was an interactive job. Now, how do you translate this into an actual job? And so for this, I'm going to copy this line up here. And then I'm going to open a file, and then I'm going to put all these options into a text file that is then going to be a script to submit a job as a batch job. Okay, I'm going to use Nano as an editor, and I'm going to call it test script, and pressing enter. I now have a file open. I can now copy that line that I've used for the interactive job in here, and now I'm going to translate that into a submission script. And so I'm going to go to the start of the line. And so the first thing I need to put in there is a hash, an exclamation mark, and then bin bash. And that signifies that this is a bash script that I'm going to use. Now I have to translate all of these options into proper Q options, and to signify that, all the lines will start with a hash PBS, which means that this line is a directive to the queue that the queue should look at. And so PBS -a, and then the account string is our first directive. I'm now going to add an additional directive again with the hash PBS, and that is the minus capital N option, and that can allows a user to give the job a name. And so my first, maybe the first test, let's put that in. For job submission names, try not to have it start with a number or a funny symbol. Letters are best. Usually keeping it to 8 characters is advisable. This is a bit 1, 2, 3, 4, 5, 6, 7, 8, 9. That's okay. So in a short qstat output, some of those letters might be cut off, but try and make these names distinguishable and not the same for every single job, because otherwise it's going to be very hard to find them in a qstat output. So this is a way of making sure you know which job is which by giving it a meaningful and a distinguishable name. Okay, so the next one now are our resource requests, and again we're going to do the hash PBS as a Q directive, and then we've got the -l, select, ncpus, and memory, and we're going to do a new line with the walltime. And so this is a very basic qsub directive to the queue, and now you can have things like module loads, for example, in here, and then load a software module, or you can have your Python script executables there, or an R executable, or any other things that you would usually type on a command line to execute or start the calculation you wish to do. I'm just gonna use an echo, and I type in my first job as a little output that could be seen in the end. And so this is now a working qsub script. Okay, let's save that. So Control O will write this out, and then Control X will exit that. If I now do an ls, I have the test script in there just to check it. Cat test script. There we go, that's our test script. And now to submit this to the queuing system, I type qsub and then the name of the script. And if I press enter, it's now given the job a job number, which is that. And if I type qstat -u eq Hank, I've got nothing running. Okay, so it seems to have finished, which is good. Let's see if it did anything at all. So let's do an ls again. And now I had the test script before. I've got 2 new files that have appeared here. And so the first one is the standard error file, and the second one is the standard output file. Let's have a look at the standard output. Let's put this in here, the .o file. And so any Q job will produce these 2 files, and they are important. So any output that usually is put onto screen will end up in the .o file, and any errors and also information about the actual job will be put into the .e file. So it's important that you keep them or look at them, specifically if something goes wrong. And you will also need these if you want to debug or problem solving, because If you submit a request for help for your help desk, they will most likely ask you for those files as well. So what's in this one? Okay, and there we go. So I had the echo my first job, and that has appeared in the standard output file. Now let's have a look at the .e file and see what's in there. And there's quite a bit more output in this. And so if you remember the interactive job, it had this little first bit here as well when it started. So the execution started, it's giving the job ID, username, and then it's given the actual host name, and then it's giving the execution history. And that is a very important output because here you have the resources requested. So that's what we asked for, but here's the resources used. And so we asked for one CPU, and we used 100% of that CPU, so that's good. We asked for 50 gigabytes of RAM. We didn't use all this. We only used about a megabyte here. And also the wall time was 1 hour. We used about 8 seconds for that little echo command. The other thing it tells us that the queue it ran in, which is the general queue, and also an access status of 0. And so sometimes if there is an error, it will actually end up between these two lines here, and then you would have a different access status, usually a minus number or a positive number. But standard queue errors or execution errors will end up in between these two hashed lines. And so if your job is stopping for no reason, this is the way to have a look and see what the queue is telling you what might have gone wrong. Okay, so the qsub command is the way of submitting jobs, either as with a -I option as an interactive job, or you can have a script or just basically a text file that contains all the directives to the queue in there to submit as a batch job to the queue.